Alright, welcome to the next lesson 4.2. One thing I do want to add is that I did mess up on this last one. Apparently, I was looking still at this minus sign instead of that plus sign as I was looking up and not really focusing right there. And so, we're going to make sure that we change all these plus signs to minus signs. And so it's just going to be minus, minus, minus. And so therefore that's what our solution should have been. Negative 2x squared minus 6x minus 1. You get the 2x. Alright, so now we're going to talk about reduction of order. And let's go ahead and consider this second order linear differential equation, a sub 2 of x y double prime. Alright, so L, that's equation 1. Alright, suppose y sub 1 is a non-trivial solution of 1. So y sub 1 is a solution to our differential equation. In order to find the general solution of 1, we need to find y sub 2 so that the set of functions y sub 1 and y sub 2 are linear independent. Since y sub 1 and y sub 2 are linear independent, their quotient y sub 2 over y sub 1 is non-constant. So if y sub 2 over y sub 1 is non-constant, then we know this is going to be equal to some function. So we'll call that function u of x. We'll find y sub 2 by plugging in y sub 2 of x equals u of x, y sub 1 of x, in this method is called the reduction of order. So we know what our y sub 2 of x should be. It should be u of x, y sub 1 of x. All right, let's go ahead and we're going to substitute or plug in. So let's go ahead and take our formula. So we have take our second order differential equation, a sub 2 of x, y double prime, plus a sub 1 of x, y prime, plus a sub 0 of x, y, to equal 0. And the first thing we're going to do is we're going to want to put this in standard form. So let's go ahead and divide everything by a sub 2. When we do this, we're going to get y double prime plus a sub 1 of x over a sub 2 of x. We're just going to call that p of x. So p of x, y prime. And then plus a sub 0 of x divided by a sub 2 of x. We're going to call that qx, y. And then we set that equal to 0. Okay? All right, now, we're going to p of x and q of x are made up of, the division of the a sub 0 of x. And we know that y sub 1 is a solution of our differential equation, and that doesn't equal 0 for every x in the interval. If we define y is equal to u, actually we'll just, let's go ahead and say, let's just call y is equal to u of x, y sub 1 of x. So it is taking the place of the y sub 2 of x. I just want to have to keep writing y sub 2 of x. All right, so if it takes that place, then we know that y prime is going to be, and I'm going to start writing this without the x's. So we know that y prime is just going to be the derivative of, u, which is going to be u prime times y sub 1 plus the derivative of y sub 1, which is going to be y sub 1 prime times u. And then we want the second derivative, so let's go ahead and take the second derivative, y double prime. Let's just zoom in. So y double prime, and that's going to be the derivative of u prime, which is going to be u double prime, times y sub 1 plus y sub 1 prime times u prime, plus, and then we have the derivative of y prime, which is y double prime times u, plus the derivative of u prime. Notice that we are going to have like terms, so I'm just going to go ahead and erase this, and I'm just going to put a 2 in front of this. All right, so plus 2y prime, u prime. All right, so now that we have that, let's go ahead and substitute in to our differential equation over here. So then substituting, we're going to get y double prime, which we said y double prime to be u sub 1 y sub 1 double prime plus 2y sub 1 u prime, that's prime 2, and then plus y sub 1 times u double prime. I don't know why I put a sub 1 there for u. Alright, plus, and then we have p, we'll just call it p times y prime, which our y prime we said was u sub 1 y, u sub 1 y, u sub y prime y sub 1 plus y sub 1 prime u. Alright, and then put that as bigger parentheses so you know that that's not inside that function, plus q times y, which we said is u, so times, we'll just say u y sub 1. Alright, now what we're going to do is we're going to break this up, so let me just keep that all right there. And that all equals 0. Now let's go ahead and break this up, and we're going to say u is equal to, y double prime, we're going to say y sub 1 double prime, plus p of y sub 1 prime, and that's not equal u, it's going to be, we're going to pull u out, plus q y sub 1 plus, and then we'll write what's left, y sub 1 u double prime plus, and then we're going to pull out 2 y sub prime plus p y sub 1 times u prime equals 0. Alright, so just to show you what happened, what I did was all this right here, alright, is coming from pulling out the u. So right there, right there, and then the q right there. And all we did is we pulled the u out, and so we're able to rewrite this. And the thing is, the reason why we want to do that is because that's going to equal 1, and then the same thing we did with this. We could just kept this right there, and then the 2y prime plus py, that's going to come from this part, and then the 2y prime u prime. Alright, so we just pulled all of that out just so that we could rewrite this to be this. We know all of this right here from the original is just going to equal 1. So, it's going to equal 0. So if that's 0, then what we're left with is y sub 1 u double prime plus 2 y sub 1 prime plus p y sub 1 u prime. That equals 0. Alright. And because we have it written in this format, alright, because we have it written this way, what we can do is, let's go ahead and use some substitution. Let's go ahead and say u double prime, or say u prime, say u prime is equal to w. That means u double prime is going to equal to w prime. And the reason why we want to do that is because now we're going to change this to make it look like, oh, this is going to be a linear first order differential equation, to where we have this y sub 1, and this comes from right there, y sub 1 times w prime plus 2 y sub 1 prime plus p y sub 1 times w equals 0. So now this looks like a linear first order differential equation. Alright, and now hopefully you observe this is both linear and separable, and so what we can do is we can go ahead and separate the variables, and hold on, I'm sorry. Let's first, again, make this linear. So what we're going to do is we're going to divide everything by this y sub 1. So again, we want to get the w prime by itself. So we're going to divide everything by y sub 1, and we get w prime plus, and it looks like we're going to get 2 y sub 1 prime over y sub 1 plus, since we're dividing that, we're just going to get P times W equals 0. All right. Now, what we can do is we can go ahead and say that W prime is just going to be dW over W plus, and then we can say the 2y prime, 2y sub 1, y sub 1 dx plus P dx is equal to 0 by dividing that W and go ahead and making sure that we put in our differentials for our P's, and then we're going to take everything over to the right hand side, so except for the dW over W. So dW over W is equal to negative 2y sub 1 prime over y sub 1 dx plus, minus P dx. And now we're going to take the integrals of all those. And, I'm just going to go ahead and take it of this. Now, I'm only going to take it of the first two, all right? So, I'll have natural log of W is equal to, and then on the right-hand side, I'm going to have, I'm going to take the integral of just what's over here on the left. I'm just going to take the integral of this. I'm going to keep the integral over here on the right, and there's a reason why. All right, so when I take that, I'm going to get negative 2 natural log y sub 1. All right, and the reason for that is because, what's the derivative of y sub 1, y sub 1 prime? So that's why it's, the natural log. So plus C minus the integral of P dx. So I'm going to rewrite that. So I'm going to bring this minus 2 back to the left-hand side and get natural log W plus 2 natural log y sub 1 is equal to negative the integral P dx plus C. And then I'm going to go ahead and combine my natural logs. So I get natural log of W y sub 1 squared, put the 2 out, properties of logarithms, is equal to negative integral P dx plus C. And now I'm going to go ahead and get rid of my natural log by putting in the exponential to both sides. And so I'm going to get W y sub 1 squared is equal to e to the negative integral P of dx. That plus C is now going to come in front, and I'm going to go ahead and say, call that C. And let's go ahead and call it C sub 1 because there's going to be another C that's going to be involved here. And now what we're going to do is we're going to resubstitute. So we are going to solve our last, so let's go ahead and solve this equation for W. And we're going to divide everything by that y sub 1 squared. So W is equal to C sub 1 e to the negative integral P dx all over y sub 1 squared. All right, and now we're going to go ahead and resubstitute. So what do we know W to equal? Well, at the top we said W, right here, we said that W was equal to U prime. So then we can say W is equal to U prime. So therefore, what we can say now, let me write that W a little better. So W is going to equal U prime. So then we can go ahead and make this equation. U prime is equal to C sub 1 e to the negative integral P of dx all over y sub 1 squared. And let's go ahead and we can integrate both sides again. Integrate, and so on the left hand side we get U is equal to, and then on the left hand side or right hand side we can say we can pull out that constant c sub 1, and then we're going to have the integral e to the negative integral p of d of x over y sub 1 squared. And because we already took the integral on the left-hand side, let's go ahead and write the plus c, and that's going to be plus c sub 2. All right. Now, we can choose c sub 1 to equal 1 and c sub 2 to equal 0. And from, so we're going to say c sub 1 is equal to 1 and c sub 2 is equal to 0. And then from what we said, y is equal to, or y sub 2 is equal to u y sub 1, then we can go ahead and write this as and here we go. Now we see everything. Y sub 2 can be found by taking the integral of e to the negative integral p of dx all over y sub 1 squared dx. I think I forgot to write my dx down here too. All right, and so this is our equation that we're going to be working with to find our y sub 2. So we need to put it in standard form in order to do so.